Question 15. The diagram shows part of a net of a cube. Add 1 square to the diagram to complete the net. Okay, this is going to be a pencil problem. Now, it really matters where we put the square, because if we don't put it in the right place, we're not going to build our complete cube. Now, if we look at this and imagine how it's going to fold over, these 4 squares in a row could make the top side, bottom side. So that'll be fine. This one could fold up to make the front, so my other square has to go somewhere on this side. Imagine that will now fold up to make the back part of the cube. Part B. On the diagram, shade 2 faces that to show how this can be done. 2 opposite faces are to be shaded. So again, we've already tried to imagine that if this was the bottom of our shape, so if we shade this one in, we've got to think, which of these other squares is going to be opposite this one when folded into a cube. Well, obviously it's not any of the ones next to it. If that's the bottom, that'll be the side, this one would be the top. So it'd have to be this part here, which would be opposite. Now again, we could have chosen these two. Could have chosen the new one we added and the one at the bottom. As long as they're not touching and they're only 1 square away, they should fold to give us an opposite side. Write down the number of edges that the cube has. Now, an edge is basically a line. It's the point, or the line where 2 faces meet. So if we have a look at a cube, I'm going to redraw it, because what we've got are some of the edges that will actually touch. So if we think we've got 4 at the front, 4 at the back, 1, 2, 3, 4, which means there are actually 12 edges. If we tried counting all of these, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. But there are a lot that overlap, so it's safe just to draw yourself a cube and imagine how many edges there are that way.